Hello students, in our previous videos, we learned about distance formula and how to use distance formula to solve some problems. In today's video, let us learn about another formula called section formula. The section formula is used to find the coordinates of the point which divides a given line segment into two parts, such that their lengths are in the ratio m:n. Let us say it like this. Say there is a point P which lies on the line segment AB, such that it is between A and B, that is A-P-B. If you observe, you will find that P is between A and B, and it divides AB in two regions. One between A and P, called as section AP, and second between P and B, called section PB. Such a division is called internal division. Now, let us assume that whole line segment AB is equal to 10 cm. And if P is at 3 cm from A, then we say that AP is equal to 3 cm and PB is equal to 7 cm. Now, write them in ratio form. So we get AP is to PB is equal to 3:7, or AP upon PB is equal to 3/7. Now students, if we add another point, say Q, near to B, then we observe that AB has three sections now. Such a situation is called as trisection of AB, or we can say that AB is trisected by points P and Q. Now students, let us take these 2 points A and B on coordinate plane, and point P is given in the same coordinate plane which divides AB in some sections, say M and N. Can we find the coordinates xy of point P using section formula? Yes, we can. This formula is when point P internally divides line segment AB in the ratio m:n, then the coordinates of point P are given by m into x2 plus n into x1 upon m plus n, comma m into y2 plus n into y1 upon m plus n. Now let us derive this formula. For that, say we have a line segment AB and point P such that AP is to PB is equal to m:n, or AP upon PB is equal to m upon n. Now let's draw perpendiculars AR, PS and BT to the x-axis from points A, P and B respectively. Next, let's draw a line segment AQ and line segment PC parallel to the x-axis. Observe that in these triangles, angle Q and angle C are right angles, and angle A and angle P are corresponding angles for two parallel lines AQ and PC and their transversal AB. Therefore, angle Q is equal to angle C and angle A is equal to angle P. Thus, by angle-angle similarity criteria, triangle PAQ is similar to triangle BPC. And as we know that if two triangles are similar, then the ratio of their corresponding sides is equal. Therefore, AP upon PB is equal to AQ upon PC is equal to PQ upon BC. Now observe the figure carefully. From the figure we get AQ is equal to RS is equal to OS minus OR, which is equal to X minus X1. Also, PC is equal to ST is equal to OT minus OS, which gives us X2 minus X. Here also, PQ is equal to PS minus QS, as P-Q-S are collinear. Therefore, PS minus AR is equal to Y minus Y1. We also get BC is equal to BT minus CT, as B-C-T are collinear. Therefore, we get BT minus PS is equal to Y2 minus Y. Now we know that PA upon PB is equal to m upon n. And substituting values of all the values in equation 1, we get m upon n is equal to x minus x1 upon x2 minus x, which is also equal to y minus y1 upon y2 minus y. To find out x coordinate, let us solve ratio of m and n and ratio of x coordinate. And to find out y coordinate, we will solve the ratio of m and n and ratio of y coordinate. Therefore, let us solve one part of equation together and then second part together. For first part, we get m upon n is equal to x minus x1 upon x2 minus x. After cross multiplying, we get m into x2 minus x is equal to n into x minus x1. Therefore, mx2 minus mx is equal to nx minus nx1. On further solving, we get mx2 plus nx1 is equal to nx plus mx. Therefore, mx2 plus nx1 is equal to x n plus m. Therefore, mx2 plus nx1 upon m plus n is equal to x. After rearranging, we get x is equal to mx2 plus nx1 upon m plus n. Now, for second part, we get m upon n is equal to y minus y1 upon y2 minus y. After cross multiplying, we get m into y2 minus y1 is equal to n y minus y1. Therefore, my2 minus my1 is equal to ny minus ny1. On further solving, we get my2 plus ny1 is equal to ny plus my. Therefore, my2 plus ny1 is equal to y into m plus n. Therefore, my2 plus ny1 upon m plus n is equal to y. After rearranging, we get y is equal to my2 plus ny1 upon m plus n. This is the formula to obtain the coordinates of any point that divides a line internally. It is known as the section formula. Now, what if point P is the midpoint of line segment AB? So we can say that it is at equal distance from A and B, or in other words, AP is equal to PB. Say, for example, AB is equal to 10 cm and P is at center, that is 5 cm. Therefore, AP is equal to PB is equal to 5 cm. Therefore, AP upon PB is equal to 5 upon 5 is equal to 1 upon 1, or AP is to PB is equal to 1 is to 1. Now, can you tell me what are the coordinates of P in this case? Observe that point P is the midpoint of line segment AB. Therefore, point P divides the line segment in the ratio of 1 is to 1, and hence m is equal to 1 and n is equal to 1. Therefore, formula reduces to both the parts. Let's see for first part. X is equal to mx2 plus nx1 upon m plus n. But here m is equal to 1 and n is equal to 1. Putting it in equation, we get x is equal to 1x2 plus 1x1 upon 1 plus 1, which gives us x equal to x2 plus x1 upon 2. After rearranging the terms, we get x is equal to x1 plus x2 upon 2. Let's see for second part. Y is equal to my2 plus ny1 upon m plus n. Now as m is equal to 1 and n is equal to 1, after putting these values back in the equation, we get y is equal to 1 into y2 plus 1 y1 upon 1 plus 1. On solving, we get y2 plus y1 upon 2. After rearranging the terms, we get y is equal to y1 plus y2 upon 2. Thus, coordinates xy of point P are given by half the sum of x coordinates and half the sum of y coordinates of points A and B. This relation is known as the midpoint formula. We will solve some problems based on section and midpoint formula in our next video.